I have a question. If I buy a pound of smaller bananas and a pound of larger bananas, each for the same price, then which one is a better deal? And that might seem like a trick question, but I promise you that one of these is a better deal than the other. And the reason why is the same reason why it's hard to build really large buildings and why it seems like insects have super strength. But to understand why, it's helpful to instead look at an apple. If we treat this apple as a perfect sphere, here are the formulas for its volume and surface area. Both depend on the sphere's radius, but while surface area is based on the square of the radius, volume is based on the cube of it, meaning that as our sphere gets bigger, volume increases much faster than surface area. In fact, when the sphere's radius increases 10 times, the surface area will increase by 100 times, while the volume has gone up 1,000 times. This is what's known as the square cube law, and it explains a surprising amount about the world around us. For example, the amount of heat an animal produces is based on its volume, whereas the amount of heat it loses is based on its surface area. And because of this, larger animals with low surface area to volume ratios can easily overheat, whereas smaller animals, like shrews, struggle to stay warm enough to even survive, having to consume up to 2 times their body weight per day to avoid freezing. Or as another example, imagine these two animals were falling through the air. The force of gravity pushing down on them is based on their volume, while the force pushing up from air resistance is based on their surface area. And because of this, the elephant will fall faster and hit the ground harder, whereas the shrew will fall more slowly and hit with less force. And this explains why smaller animals like cats and mice seem to be able to survive impossibly high falls. In fact, you could throw an insect like an ant out of an airplane and it would actually survive hitting the ground. And examples of these effects of size are all around us. Because of how the force of someone's mass is distributed throughout a bone, bone strength is relatively weaker for larger people, leading to more bone and joint injuries for athletes who tend to be larger people. Small animals and insects can easily lift many times their body weight thanks to how muscle strength scales with size. And larger buildings require much more reinforcement than smaller ones to not crumble under their own weight. And this brings us back to our bananas. Although larger bananas do have thicker peels, the peel doesn't grow as fast as the part we eat. So when bananas are priced by weight, if you're buying smaller ones, that usually means that a bigger percent of what you're paying for is peel. If you don't believe me, then check this out. Here I have a bunch of smaller bananas and a bunch of larger bananas. And if I first weigh the entire bunch, peel the bananas, and then weigh the peels alone after, I can calculate what percent of the total bananas were peel. And what I found is that with the smaller bananas, 42% of their total weight was peel, whereas with the bigger bananas, it was only 38%, which means that going with the larger bananas instead of the smaller ones would give a cost savings of, drum roll please, 8 cents. Follow for more financial advice.